our last example. This is a bit more advanced because now we have three forces. So when we have three forces acting on a stationary object, and we only know one angle and one force, we need a modified method to solve these types of 2D problems. So we need to redraw all forces using the tip-to-tail method to form a right angle triangle. So say an object is hung from two wires as indicated. Find the magnitude of tension in each wire. So let's just start by drawing our free body diagram. So here, let's say this is tension 1, or we'll say FT1, because we know that's force and tension. So FT1, and coming out from the other side is FT2. There's one more force acting here. What is it? The gravity, yeah. So draw from the middle down, and we have our FG. So now we're just going to redraw this because we have, since it's a free body diagram, all of our arrows are tail to tail, right? So we're just going to redraw all of these vectors into one triangle, okay, so that we can use our trigonometry, etc. Did I hit the record button? Oh yeah, I did. It's going. Okay. So now we will redraw vectors using tip to tail method. So let's draw the FG going down first. So we have our FG, because I know that's going straight down. And our tension 1 was kind of going off to the northeast kind of side. And then we have our tension 2. So FT2 and FT1. So FT2 and FT1, we know that they're at a right angle to each other. So then we can say this is the right angle. If tension 1, if we look back at the beginning here, tension 1 was at a 70-degree angle to where it was hanging from. So when we changed, so here we would say this was the 70 degrees. So if this is all in total right angle, then this angle between, or this angle of FT here, would be 20 then. So this theta is equal to 20 degrees. Okay, so now we can work with that triangle to kind of figure things out. So the question's asking me to find FT2 and FT1. Well, all I have right now that I know about is my mass and the angle. So how can I figure this out? Yeah, so I can find FG for sure using FG equals m times g. And then I can just use my trigonometry math to solve the other sides. Pardon me, sorry? If you were to label like this vector, yeah, you would label this as a negative because it's going down. But in order to find like your different sides, you don't need to put negative into your trig function. Yeah, because it's just when you're finding trig, you're finding magnitude, not direction, right? So you don't need to include negative in a trig equation. So our FG is equal to m times g. So FG then is equal to 37 kilograms multiplied by 9.81 meters per second squared. So FG then is 362.97 newtons. Cool, so that's my hypotenuse. So in this equation, this is my hypotenuse. So now I can solve for my two sides. So say for T1, or FT1. So this is, I'll use my cos function because adjacent over hypotenuse. So cos of 20 degrees is equal to T1 over 362.97 newtons. So my T1 is equal to 341.08 newtons. So, or sorry, I should say FT. FT1, then we can conclude with our sig digs that it is 341 newtons. You don't need to put direction because the question said what is the magnitude of the tension. If it just said what's the tension, then you probably should. So to find FT2, use sine. So sine theta is equal to T2 over 362.97 newtons. So T2 is equal to 124.8